Hi, Rahman, this is session 5 SELinux Policies, SELinux Administration course. Okay, in this session, what we are going to learn is about what is a policy, how the policies are organized, that is SELinux policy organization, confined and unconfined domain concept, SELinux policy behavior, configuring policy with SEManage, examples with regard to port labeling, how to manage port with SEManage, using SEManage Permissive, limiting flow based on network interface, generating policy files for deployment, handling device files and setting an SELinux label on a device node. An idea about this topic. So broadly, if you see, one line agenda of this session is a policy. If we don't know details about the policy, this session, by the end of the session, you'll understand everything about the policy. So SELinux implement different policies like targeted policies, MLS policies. When we say target, the default policy applies access control to certain processes or targeted processes. We are going to develop in our session 7, we have our agenda that how to build a policy. We'll be downloading a source file from the repository, we'll building our own policy, and we'll use that instead of the existing default targeted or MLS policies. So we are going to work with that. That is compiling and deploying custom policies or policy from the source file. That is there in session 7. MLS multi-level security. Okay. Now SELinux policy set the SELinuxType directive in etc SELinux config, where we set this and where we notice the config file where we set this type. With the targeted policy, the targeted process run in their own domain called a confined domain. In a confined domain, the files that a target processes has access to are limited. Meaning is very clear. Let's emphasize once more. When you are using a targeted policy, the processes run in their own domain. That domain is called confined domain. In confined domain, the files that targeted processes has access to are limited. Means the targeted process can access only limited files because of confinement. It is something like somebody has put into a building and the building is locked from outside, and you say you are confined to this building. That means you can access anything and everything within the building but not outside the building. That is the right word, dictionary meaning of the word confined. So therefore the processes run in their own confined domain means giving access to the limited number of files on the system. That is the meaning of the sentence. If a confined process is compromised by an attacker, that clearly means if a terrorist attack happens, if something happens in a building, then you are limited, the damage is limited to the building, not outside the building. So if a confined process is compromised by a hacker or attacker, the attacker access to the resources and possible damage they can do is also limited. Now quote unquote limited to that confinement, limited to that building, limited to that domain, not outside the domain, not outside the boundary. That is the advantage of this targeted policy. SELinux denies access to these resources and logs the denial, whatever denial. If that attacker or hacker try to access the resources outside the domain, then you will be denied, or the process will that will be denied, and whatever denials are happening, they will be logged. So what all you were trying to access and what all were denied. That is how SELinux policy works. So how it works? It works like this. We have a concept of user. Users have role. So role determine what users are authorized. The role take a decision on the user authorization. So role decide what user are authorized, right? Then we have the domain. Domain determine what roles are authorized. So domain decide what roles are authorized. Role decide what users are authorized. And then we have the file, actually where the work is happening, which is being accessed by the process. So file, domain can access certain type of files, only limited number of files. So ultimate is we are protecting the files. So file access is controlled by the domain, and domain have their own limited number of roles, selected roles, and roles have selected set of users. So if you go from this side, we have multiple users, having the roles, role having access to domain, and domain have access to the file. That's how the policies are organized. So this is the policy organization chart, which will make you understand how the policy act on a given file, how a policy control a given set of files by means of domains, and domains thereby roles, and roles thereby users. So ultimately user acquire a role fit into a domain, and domain have confinement on the file, that only selected domains have access to selected files. So that is what how the policies are organized. So domains can access certain type of files only, not every type of files. It is depending on what type of files are allowed for the domain to be accessed. That's how the policies are organized. Confined and unconfined domain. As we discussed in the previous slide, just to understand that, confined means there is a boundary drawn. Unconfined means there is no boundary drawn. Simple. So specific services are placed into distinct security domains that are confined by the policy. Meaning is as usual as we have understood so far, that the boundary is drawn outside the files, and which is known as a domain, right? So for example, a user runs in a completely unconfined domain, meaning is user is allowed to do anything and allowed to perform anything, that is unconfined, no control, no boundary. While a services that listen on a network for a client request, such as named HTTPD or SSHD, run in a specific confined domain. And that is obvious because attackers or the user try to attack the service, not the user. Nobody get attacked directly on the username or users. The attacks are on the services, what services are working, and therefore the services has to run in a confined domain. Services has to have their own area. Services have to have their own limitations. Therefore services that that are listening on a network for any request, let it be named service, HTTP service, or SSHD, they run in a specific confined domain, so they are restricted. So we control the subject, we control the domain, we control the services rather than the user. So when the users are controlled, because ultimately we try to access the files through the services, and when the services have control, just like okay, let's take example. I want to open a website. I'm a user, I want to try to access a website. Now website means there's a process running in the backend. The HTTP process is running. So what I can do through the website, I have to do through the Apache web server, because ultimately Apache is going to serve me the file. So we have to control the Apache. So Apache will have limited access to selected given of files and the operations that are allowed to Apache web server. Processes that are not targeted run in unconfined domain. Now again, we cannot have all the processes, and we don't have all the processes running in confined domain. So the processes which are not targeted, not specified in the policy, not targeted means not specified in that, not defined. So processes that are not defined, not targeted, they run in unconfined domain. That means the possibility of damage is there with these such processes which are running in unconfined domain. If an unconfined process is compromised, obviously there is a possibility of damage. So if an unconfined process is compromised, SELinux does not prevent an attacker for gaining access to the system resources and data. DAC rules will still apply to an unconfined domain. Obviously discretionary access control meaning is permissions, file permissions and authority. So those rules will still apply, but SELinux will not apply. SELinux security will have no control on that kind of access where the process is running in unconfined domain. For example, kernel T domain, unconfined kernel process is run in this domain. Unconfined T domain, Linux user logged into the system run in this domain. A listing of etc SELinux with targeted MLS policies installed. You can verify that what all policies are installed. You can use ls-l or ll/lrt or ltr etc SELinux. And this will show you all the policies installed, and we will take a look at, because let me explain some more commands. After that we'll in one step we'll go to the system and we'll take a look at these commands. Okay, SELinux policy behavior. SELinux policy is not something that replaces traditional DAC security. SELinux security decisions comes into play after DAC security has been evaluated. So as I said earlier, that is, it is a second level of security. When SELinux enabled system starts, the policy is loaded into the memory. SELinux policy comes in modular format. They can be dynamically added and removed from memory at runtime. So the policy store used by SELinux keeps track of the modules that have been loaded. And SE status command shows the policy store name. And if you want to see all the policies, we can take a look at SE module -L, and we'll take a look at that. Now let's go to the system and let's try these two commands. First was that what is there in etc SELinux, and second is this SE module commands. Let's take a look at. Okay, so here we are, ls-ltr/etc/SELinux, and this will show you the policies. So this is a targeted policy, and this is MLS policy. If you see here, is not installed on my system. So this final or this temporary, these are additional files, but the policy, if you look at, is only the targeted policy. This is there. Rest is configuration file and config. So I have only one policy right now, targeted. What all is available? If you go to the targeted, we can take a look at that. /etc/SELinux. Typo. Okay, cd targeted. So here we have context, we have logins, we have modules, we have the policy. So policy is under this policy. So we are working in etc SELinux targeted policy, and you see the policy is 0.31, that is 31 is the policy number. The same will be reflected if we type SE status. This will show you the policy store. So policy store, the target is the policy name. As I said, my loaded policy name is target. It is running in permissive mode, and policy version is like 31 number. That is how the policies are defined. So let's take a look at the modules, all modules in the SE module. So we can use SE module -L, and there's a lot of, so you can use pager to see all the modules. So all policy modules will be visible and they are displayed here. Now rather than this is not the right approach. What is the right approach is we take what we want. So for example, we want to see what all SSH related modules are there. So I'll simply type grep SSH. So I can find out what all modules are there which control SSH behavior. So this is SSH policy module, which is version 2.4.2, and there is RSSH also. Same way HTTPD. So this will show me all HTTPD modules and the version of the HTTP modules. So permissive HTTPD, there is no version number. Same way we can take a look at whatever we want. So whatever policy we want to verify about a given service, we can use the policy SE module -L to see the policy version and which policy version has been implemented for that particular service. So we can use filter to find out the policy names and policy details. So SE module, SE status shows the policy store name. We discussed that. SE module -L shows the list of the modules. SEManage is configuring a policy with SEManage. Now we know which policy modules are loaded into our system. So we can control them. We can modify them, modify the behavior. So we can configure the certain elements. In fact, we can configure certain elements of the policy without actually modifying the policy itself or recompiling the policy source. This is by design actually. You know that Linux is designed in such a way that it allows you to configure the behavior of Linux and thereby any application of Linux. The configuration has to be strength of entire Linux system, Linux operating system itself, because every application in Linux I have observed that give you a facility of configuring it, modifying the behavior, how it works. So that is the power which comes with Linux. Therefore SELinux also is not an exception here. So SELinux also can be controlled, the policy can be controlled, the modules can be controlled using SEManage. So SEManage is a tool used to configure certain elements of SELinux policy without modifying or recompiling policy sources. This includes mapping Linux username to SELinux user identities and security context mapping for objects. Ultimately, this is what is controlled and this is what is done by the policy. So therefore we can control that also. We can modify that. Security context mapping for objects like network ports, interfaces and hosts. By default, SELinux only allows known services to bind to a known port. Of course, by default. That means if you want to bind an unconventional, non-common port to a given service, you can do so. I remember a recent example where I was teaching MySQL DBA to a participant, and our lab assignment required that we want to run multiple MySQL instances. Now MySQL listen on a given port number 3306. Since 3306 is the standard port for a given service MySQL I had to allow port number 3307 or 3308 for additional instances. So that would not have been possible without this concept, which is SELinux policy behavior change or configuration with SEManage. So I used this command SEManage to bind that non-conventional port, a non-common port, to my MySQL, right, to that module. So I did that. If you want to modify a service to use a non-default port, we need to modify the port type by SEManage command, and this is what I did in my case to allow MySQL to listen on another additional port number 3308 and 3307. That is called port labeling actually. And that's whatever I explained, the example was example of port labeling, and we did that. So SELinux policy controls every action that a process can execute on a certain object, such as a file, a device, or a network socket. Opening a TCP socket and listening to a network port are examples of actions you can control and restrict via SELinux policy, and this is what we want. And this is how we implement the security, and that's more than sufficient for us to control the behavior to secure our system. So if a service is configured to listen to a non-standard port, by default SELinux targeted policy will deny this action. Simple. So if you are undergoing training on MySQL, as I can quote this example now, and you don't know how to relabel the port and SELinux is enabled on that system, you do whatever configuration you want, man, but you will not be able to get your MySQL running. I'm talking about non-standard port. Why? Because you need to have SELinux understanding for that. You need to configure that additional port. You need to allow that port through SELinux, because by default you are allowed only on 3306, not on 3307. So we can take a look at what all ports are, and we can look at what all settings are, and we can see which service is running on which port. Let's take a look at. So now we are looking for SEManage. Good point is you can use the tab key here. It is a very good command line completion option. I just press tab key and I can see what all options are available. So I type P and I'll get option port, right? And -L will give me all the ports, but of course I want to grab let's say MySQL. That is what I wanted to show you, because I allowed 3307, 3308, and that's how I added. Look at this: 3308, 3307. The default one was 3306, and this is the range. This was allowed MySQL D port, and even the range is allowed. Non-standard port, they are allowed, right? And this is the port. Same way you can look at the ports for HTTPD also, HTTPD and the HTTP proxy. So all port related to HTTP or HTTP proxy can be seen here. So you can check if you have to configure a service on a non-standard port, non-default port, you have to take help. You have to configure it through SEManage. So this is how we can verify that, okay, whether the given port is open from SELinux or not, right? So SEManage port -L will give you the list of that. In fact, just to show you SEManage, let's say you press tab key and you see everything. Login -L, it will show you all the logins. The process is quite simple. When you type whatever, you type -L after that. For example, interface -L. So list will give you now we need to understand the how they are structured, how we can use the command. So you change and you'll see the details of that. For example, now I want to see let's say user. I want to see the list of users, and we'll see all those 7-8 users here. Yes, we see that list of users. So SEManage followed by tab key is a very good option. SEManage, then followed by tab will show you the boolean. For example, -L will show you all the booleans. So SEManage will control how you configure, allows you to configure the policy. -L is just to show you the configuration part or the values, current values. Let's move on. So this is how we can use grep command -L, right? So how we can verify the existing. Now we need to understand how to add the new one. Let's add this. So we saw that this also like port HTTP port T, regulate the port that Apache can listen to, and this is we can simply use grep command to grab the HTTP port, and this is the port T. this is the label which actually actually regulate the port that Apache can listen to. So, and cache port T identify the ports allowed by the web proxies. So web proxies in this case are allowed to listen on these ports. The web server itself, the Apache web server itself, is allowed to listen on these ports. I want to add port number 444 because 443 you know that it is for SSL. I want to allow a non-standard port, non-default port 444 for Apache web server. So what do? I need to use this because this is the label. I need to change this type context, right? HTTP port T. I want to allow port allow port number 444 on this. So I need to use command port add type HTTP port T. Port is TCP and port number is 444. So I need to give this command in order to allow Apache to listen on port number 444. So command is quite simple: -a-t HTTP port T. Let's take a look at this. So first let's grab now we can use SEManage port -a-t and the port is this. We want to add this HTTP port T. -p TCP and 444. So SEManage port add type port P port type is TCP and port number 444. Now once it is added and we grab this command again, here we'll get this. Instead of, in addition to this default port, we'll get 444 also. Let's take a look at now. So we got 444 now. So that is how we work. So we can do our own labeling for the ports. We can add our own ports. Similarly, this is what I did for MySQL, as I said. In my case, I added port number 3307, 3308, multiple ports to allow MySQL to listen on, because my multiple instances for MySQL were running and I had to give the access to those instances. Creating ports with SEManage, which we did. In fact, this is what precisely I did. Let's create a new port for MySQL and assign it to port number 3308. And -a option is to add a new port. -t option specify the SELinux type, and -p is to specify the protocol to use, and that's what we did. So port -a-t MySQL D port T -p protocol TCP 3308. And this is what we did for similar, exactly more or less same command we did for HTTPD. To view the newly created port, we can use the command list with -c option to show only the customizations. That's a very good point, that you just want to see what all customizations you have done. So for that, for your own customizations only, you can use -lc uppercase C. That's a very interesting option, that you don't want to see the default ports. What you want to see is your own ports only. So whatever you have configured. So for that you can use SEManage -lc, in fact ports. So that will show you only the customizations what you have done. And you see, this is what I have done: 3307, 3308 for MySQL, which I did, and 444, which I I did these two also. So you can see the customizations using this command SEManage port lc. Same way, to assign a range of ports, you can specify the hyphen also. So AT type, then protocol, TCP, and the range. Range can be specified with hyphen in between. That's also allowed. Ports with SEManage. To override an existing port that was already created, you can use -m. That means you want to modify. So SEManage port -m-t unreserved port t-p TCP 3308. Basically, we want to make it unreserved. It was for MySQL, it was reserved for MySQL. We want to change it to unreserved port. So we can modify that because 3308 in our case was already assigned. I want it to release from that assignment. So for that I can use -m, that is modify. Now if we list all the ports that if we list all ports, we will see the change that this will go to the unreserved port and this will be not available in the MySQL. So that's how we can modify that. Deleting ports with SEManage. We use the option D to delete a port record. To delete unreserved port T on TCP port number 3308, you can use -d command. So SEManage port -d -t type protocol and port number. Command is same. We are just making changes, only one change here. Instead of A we are using D, we are using M. So we have different options here. And that also you can use with command line completion. That will also show you what options we have. -a for add, -m for modify, -d for delete. To delete the range, you can specify the range also similarly the way you specified at the time of creation or at the time of labeling. So -d delete the range. If you run the customized list command and it returns nothing, why? Because you have already deleted them, then the entry has been removed. That meaning is simple. If we delete and then try customize to display the customized list, we will not get anything. Using SEManage permissive. SEManage permissive is used to add or remove SELinux policy permissive modules. To list all permissive modules, you can use -l option. And permissive means don't deny only permissive modules. Meaning is don't deny, just log. That is what the meaning is. So SEManage permissive -l will allow first it will, of course we are using -l, so it will display all the modules which are permissive. To create httpd_t permissive domain, we can use -a option. So SEManage permissive -a httpd_t. Let's take a look at SEManage permissive -l, then -a, and of course then we can add or delete. So let's take a look at that. So SEManage permissive -l grep httpd, because I don't want to see it is better to use filter that will save your a lot of time rather than going through all the modules. We are interested on selected modules. So now this is httpd, right, -l. So let's add, this is already added, we can see that SEManage permissive -a. So that is already added. If you want to delete it, you can delete it. So same command permissive, what all options are there, you press tab command -, it will show you -a add, d delete, -h for help, -l for list, -n for no heading, -o. So -h, I want to see the help. So this is how you can specify the help of SEManage. So it is not that complex at all. Actually, it is so easy to work with. Only thing is that you just have to sit on the system and be cool and just try the commands one by one. Read the documentation. Help is available wherever you required it. Quite simple. Okay, it was already there in my case, so there's no point. I did not delete it, because it appears quite simple, so I thought let's move on. And this is what I just demonstrated and explained, that tab command is command completion is a very powerful, very good feature for us. So you type SEManage, press tab key, you will get all possible options: boolean, export, import, log, node, and then type one of the option which you want, then type hyphen and then press tab key again. You will see all possible options there also. So command line completion is available with this. Then again you type some of the option, for example f context hyphen a hyphen t. Now you type samba, and then you want to see what all options are there with samba. Let's take a look at that. In that case you type tab key, press tab key, and it will show you all possible options with the context also, because this is generally, the names generally are complex and we forget the names. So to get the names, you just type first few characters and then press tab key. That will show you all the possible options with that start with it. So that is very helpful. It is not complex. People take it as SELinux is very complex. No, only thing is that it requires some focus. It requires some general knowledge. So tab key, command line completion, along with this help, makes it very powerful and make it easy to use. Command line parameters can be changed in a command like hyphen a hyphen t, and that we can do. That we have already done that. Like we can specify all options in one command. We have been doing it. Limiting flow based on network interface. The idea behind interface checking is that packet that comes into a system passes an ingress check. Ingress means incoming rules on an interface, whereas the packet that goes out of a system passes an egress check, means outgoing rules. Ingress and egress, incoming and outgoing, are SELinux permissions involved, whereas interfaces are given a security context. So interface labels can be granted using SEManage tool and are especially useful for assigning sensitivity levels and categories to interfaces, as we will do in the following example, where the categories for tape drive interfaces are set. And this is what the rule is: native. So interface add type is native t hyphen r, and the role is this, and this is the sensitivity level, because we know it is a multi-level security system. So if we specify this rule, we are specifying the sensitivity. Remember we studied that top secret, the secrecy or the sensitivity level, and to this device, tape drive. So that's how we can specify, we can add the sensitivity to our tool, to our service or to our interface. Check the current setting. You can use -l. I specified that. If you remember, I use this command SEManage interface -l. Process remains the same. One thing I'm sure you might have observed, that it is not complex. What is required is little tricks, little practice. One common learning from this entire session so far is that we use the command SEManage. You press tab key, you see all the options. The first thing you should try is -l, the option after that option. It will show you all the list. Then you try one by one with -help. Then of course add, A for addition, M for modification, D for deletion. The options are also common, and then corresponding options are also available. What are the options available under interfaces? By default the interface is labeled with native, that is network interface. Native is not IFA, it is network interface -t and without category constraints. This will however not be shown in SEManage interfaces -l output, as it is default output is empty. That is the current settings for interfaces. And that's all for this session. I hope you enjoyed it. Thank you very much.